Hello, everybody. This is Professor Ma, and this is the sections on the notation, more on the notations of functions in algebra or functions. Brief recall of what a function is. Usually, we'll have it in your mathematical formula. Here's a second degree formula: x squared minus 2x plus 3. Okay. And here is the parts of a function notations. The f is the name, and the x is the input box. And this actually what the formula do, what the formula will do to the x, and whatever it produces is called y. Okay. So remember, this is called input box. It's because we get to put input into it, whatever x we want to be. For instance, here, and the request is the input box comes in. The request is process the number 2. So the function is a formula that will process this number 2. And what we do, of course, is whatever the formula x is, you input you put the input 2 in its place x. So x marks the position with the input it's going to go inputted. Okay. And then, of course, after you input that, you get the numbers. Calculation, you get a number, then number comes out. In this case, y is 3. So this is a function. Okay. And so what can we do with the functions? Well, one thing can do with function is that besides evaluate numbers, we can put in formulas. Okay, and here exercise with putting into in the formula, using formula as the input. Here we want to input the formula 2 times a. You say, what's a? Doesn't matter, just this math formula there. Okay, this one we want to input a plus b, the entirety, into for what? For x. So f of 2a, so we replace 2a in the x marks the position to be inputted, pasted, and then what? Oh, simplify, just clean it up a little bit. A lot of time, maybe in your process, this is a step we need to carry out. Whatever the result comes out, we're going to use it for something else. Okay, so just clean it up. A lot of time, just simplify. This is as far we can go. Now, one of the input for square formula we use quite often is we put into this expression of 2 terms, a sum, into a square formula. And here is a reminder, you're going to wind up using the squaring formula. Why? Because when I put a plus b into for the x, it looks like this. It's asking us to square out the expressions parentheses, which you need to use this formula, which is to remind you there's a middle term right there. Don't forget that. Okay, so the expressions, we expand that and clean it up a little bit. Actually, it's nothing to clean up, nothing to combine. So this is what this long entire output comes out. Okay. And we can use the operations add, subtract, multiply, divide. Use functions, use the name of the functions to make up a new functions in obvious manners. For example, f plus g, meaning take formula f, add it to formula g. So the symbols refer to which formula on the papers that we are working with. So f plus g means add the 2 formulas together and clean it up. We have these. And similarly, f minus g, you subtract, and be careful with the subtraction because you're going to change sign. Okay, so this is a lot of time algebra in these places, people make mistakes. Okay, and that's what the end result is. And here f times g is multiply, and this is the sort of factored form. Okay, and or you can put it into the expanded form if that particular form is needed. You can multiply out. Okay. And divide, you just get its formula. Okay. And we can also use formulas and to say that for use this formula, process the input these numbers, I get answers. But I use another formula, I want you to process with another input, I get another answers, and I want the two answers to interact in certain ways, and so all these different way of doing things. Like this example, what does this mean? Well, here's a formula F, and here's a formula G, okay? And the F of 2 require us to take 2, put it into formula F, and find out what it is, okay? And the G of -3 requires us takes -3, but this time put into the formula G and find out what that is, and combine, subtracting them. So we can do this, we can do this step by step. Let's find out what F of 2 is. We put 2 into F and see what it comes out. And put 2 into F, looks like this. And X is replaced by 2. And calculate this out is -3. 4 minus 4 zeros. Zeros again, -3. G of -3 and put -3 in there. And so this is linear is -6 plus 1 minus 5. And then we read the request to have these two answers subtracted. -3 subtract -5. Now we get the final output, okay, of this combination of these two functions results. Okay. Another things we commonly see in calculus in the beginning is this f of x plus h minus f of x. And we here is what remind us from last page, the f of x. This is the formula for f of x. Okay. So here we are actually putting two different expressions into f. Okay. And it's asking us to subtract from that this f of x just itself. Okay, so first of all, let's deal with the from part. What is that f of x plus h? Okay, that is put the input x plus h into where x is, and so we have this. And remember, square this out carefully, and so we have this expansions, and that's only this part, the from part of this subtraction. Okay, and it is asking us to subtract minus f of x from. So in other words, so the question is asking now subtract f of x. So I'm going to subtract this x squared minus 2x minus that. I know it's not very good. This is f of x plus h minus the f of x already. Okay, I just want to point out at this stage, okay, that in the expansions of these f of x plus h, okay, in the case of polynomial, this is second degree polynomial, okay, there's always a copy of f of x precisely in there. In other words, that's a copy that the parts without the h, that copy is precisely the original f of x. That's the part you want to subtract out. So in other words, if I subtract these two, what I will have is the parts that's left with h, or the terms that are left with h. Okay. And what this is in geometry, in picture, is this. Let's just take this as an example. This is a parabola. Okay, the graph of this x squared minus 2x minus 3. Okay. And we'll have the x-axis somewhere, okay? And at a point where x is here. And then this point, the height of this point, which is the y, this is f of x. Okay, that's this part. What's f of x plus h? First of all, what's x plus h? X plus h says the h, if h means a small number, a little bits, okay, h is some small number added to x. So you wind up with now at a different location. So the input is changed by h, and the output, when you plug in x plus h, this part is f of x plus h. The height of that amount, that's a y. If I plug in the number x plus h, and what's what's this subtractions? The subtraction is the difference between them, and that is from here to here. Okay. In other words, this is what we calculate the height of these things in a formula. This is f of x plus h minus f of x. That geometry. Okay. That is how much is gained when I move the input from x to a little bit more to x plus a little bit more h. How much extra gain I'm going to get in the the output. Okay, in other words, this is a difference in the output. Difference in output. Before and after difference. Okay, it's after minus before. Okay, this is what this formula is about. The abstract formula f of x plus 8 minus f of x. This for every function f. Okay. So here's another operations about function which we call compositions. Which is actually we already used it when we put one formula into another formula. Here x plus h is a formula, right? Into the formula f. We are composing them. Okay, if you put it, things in composition, language of compositions. Okay, so f composed with g, f circled g, okay, means take g of x, which whatever the formula for g of x is, use that as input into the f. Okay, so the input for the f is g of x. Okay, you read this from right to left. Whatever closest to the x, that formula is going to be used as the input. So here, gx is the closest. That's a formula. That formula is going to be plugged into the formula in front of it, f. If I turn that around, it means the closest here, in this case, the closest formula to x is f. That means to take the formula f, plug into the formula g. And here's our two examples. Okay. Where is it? Here we go. Two different examples. Plugging here's f circle g of 3, meaning g of 3 is to be put into f. But of course, I need to know what g of 3 itself is first. So I put the 3, in other words, the 3 works itself through the formula one by one. First 3 works itself through g. Put 3 into g. It's minus 9. So this now, so it works itself now. This part is minus 9. Now minus 9 is going to work through f, put into f. Okay. So that's the output. That is f circle g of 3. Here's g circle f. If I were to turn that around, that means I have to work through 3 has to go through f first, which comes out 4. Then I have these 4s go through g, and you have 1 double minus 13. Notice these are different. Okay, so that's it. So do the homework. Bye bye. Stop that.